Good morning, children. Welcome back to the science class. So, in the previous class, we have learned about acids and bases. I hope you understood that. Today, let us continue with a new topic, that is metals and non-metals from your chemistry part. Children, you might be learned about metals and non-metals in the previous classes, or at least you might be heard about metals and non-metals, and even you know the names of some of the metals and non-metals. I hope so. So today in this class, we are going to learn about metals and non-metals in details. So some of the properties of metals and non-metals you have already learned in 8th standard. Very few properties, especially the physical properties of metals and non-metals. So here we are going to focus on the chemical properties of metals and non-metals, as well as how we can extract these metals from its sources. So that is what we are going to focus in this chapter. How can we extract a metal from its source? Children, here you can see the periodic table. You already learned about the periodic table. And once again, let us revise the periodic table here. So this is the modern periodic table, what you are seeing here. And here you can see is represented by giving different colors. Here, if you observe some green color boxes, you can see like boron, silicon, arsenic, like that. Polonium, tellurium, antimony. So all that boxes, green color boxes, that elements are metalloids. You know already. They are called metalloids. That are the elements which show both the properties of metals as well as non-metals. So here in this periodic table, the elements which comes to the left of metalloids, that is to the left of the green boxes, are called metals, and those which comes at the right of metalloids, that are called non-metals. Okay, children, so all the elements which comes to the left of the green boxes, that is metalloids, are called metals. So many elements are there which are all metals, and very few elements are there which are non-metals, and still few are there which are known as metalloids. So this is what the modern periodic table. Understood, children? So the periodic table is divided into three parts. That is the left, and the major part of the periodic table consists of metals, and the right part, it consists of non-metals. Both are separated by metalloids, which are represented by that green boxes. Now, Let's study about the properties of metals and non-metals. So at the beginning, we are going to learn about the physical properties of metals and non-metals. So to study the physical properties of metals and non-metals, actually we are considering certain parameters. So they are known as the physical properties. Okay. Physical properties. So let's see what are the different physical properties we are going to consider to compare metals and non-metals. So the first one is state, that is existence. Metals are the elements which can exist in solid form. So metals are solids at room temperature. For example, iron, copper, gold, silver, sodium, potassium, all these metals, they are solids. But there is one metal which can be a liquid at a room temperature. That is mercury. Mercury is a liquid metal at a room temperature. And we are using that in a thermometers to measure the temperature. So normally metals are solids at a room temperature, and the exception is mercury, which is a liquid metal. Non-metals can exist in solid, liquid or gaseous state. Non-metals can exist in solid, liquid and gaseous state. Then the second property that we are going to learn is luster. Luster means the shining of the outer surface. What is luster? Luster means it is a shining on the outer surface. So metals are lustrous. That means all the metals have a shining surface. We know the newly taken aluminium vessels or steel boxes or gold or silver jewels, whatever it is. So it has got its own shine on its surface, and that property is known as what? A lustrous. Luster. So all the metals are lustrous, and non-metals are non-lustrous. Non-metals are normally non-lustrous. They don't have any shiny surface. But there is an exception, that is iodine. Iodine is a lustrous non-metal. Iodine is a lustrous non-metal. It is little bit shiny in nature. Okay. And the third property, that is conductivity. So metals are good conductors of heat and electricity. Metals are good conductors of heat and electricity, whereas non-metals are bad conductors of heat and electricity. Normally, non-metals do not conduct heat and electricity through it, except graphite. Graphite, which we are using as the pencils, lead. So that graphite is a good conductor of electricity. That's the only one non-metal which can conduct electricity. Graphite, which is an allotropic form of carbon. Graphite is an allotropic form of carbon, and that is a good conductor of electricity. The next, when we consider density, metals are having high density. compared to non-metals. So metals are high density compared to non-metals. You know the substances which have high density sink in water, and the substances which have low density float on water. So almost all metals they will sink in water. The next property is hardness. Metals are very hard. Metals are very hard. You know, iron is very hard. Aluminium is hard. So almost all the metals are very hard. As some of the exceptions are alkali metals, that is sodium, potassium, they are very soft. They are like pellets. We can even break them. We can powder it. So they are soft metals. Alkali metals like sodium, potassium, calcium, etc. Then non-metals are soft compared to metals. Non-metals are soft. You know, carbon. Then there is a non-metal which is another allotrope of carbon, which is the hardest substance in this world. Hardest substance, that is diamond. Diamond. Diamond is an allotropic form of carbon. Carbon is a non-metal which is soft, but its allotropic form, that is diamond, is the hardest substance ever known. So metals are generally hard substances and non-metals are soft substances. The next property is sonority. Sonority means the capacity to make sound. What is sonority? The ability to make sound. Metals are sonorous. Metals are sonorous. That means metals, when dash each other or when we beat on them, it produces sounds. Non-metals are non-sonorous. Cannot make any sound. If you drop one plate, a steel plate, it makes sounds. No, if you beat on any metallic surface, produces sound. So metals are sonorous and non-metals are non-sonorous. Again, metals are malleable and ductile, whereas non-metals are non-malleable and ductile. Metals are malleable and ductile. Non-metals are not malleable and ductile. That means the metals we can exert pressure or force on it and can be made into sheets, into thin sheets. So this property of the metal is known as malleability. If we apply force or pressure on the metal, we can make it into thin sheets. So this property is known as what a malleability. And what is ductility? Ductility is the property of a metal to be drawn into thin wires. We know that aluminium cable, aluminium wires, copper wires we are using to conduct electricity. They are all the metallic wires that we have drawn into wires. So that property is known as what? Ductility. So metals can be made into sheets or can be drawn into wires. That's why they are called what? Malleable and ductile. Metals are malleable and ductile. Non-metals are not malleable and ductile because non-metals are brittle. If we apply pressure on that or force on that, it will be crushed, it will be broken. So they are not ductile or malleable. We cannot make their sheets or we cannot draw them into wires. Next, when we consider the melting point and boiling point, metals have high melting point and boiling point. Metals have high melting point and boiling point compared to non-metals. Metals have high melting point and boiling point compared to non-metals. So what's the reason for that? You know that in metals, the atoms are very closely packed in all the metals. As metals are solids, the atoms are arranged very closely. So when the atoms are arranged very closely, the attractive force is more. Due to this high attractive force between the particles, their melting point and boiling point is high. Metals are generally solids and atoms are arranged very closely and the force of attraction is very high between the particles. Due to this, the melting point and boiling point of metals are very high. Whereas in non-metals, the non-metals can exist as solids, liquids and gases. So of course in liquids and gases, the particles are arranged loosely. The force of attraction is less compared to solids. So their melting point and boiling point is also low. So attractive force between the particles is low. The melting point and boiling point is very low. And the last property that we consider is allotrophy. Metals do not exist in allotropic forms. Allotropy means, the same substance, the same element existing in different forms with the different properties. They are known as what? Allotropes. For example, carbon. Carbon can exist as coal, that is charcoal, graphite, diamonds, etc. So all these substances are carbon only, but their physical properties are different. So metals cannot exist in allotropic forms, whereas non-metals exist in allotropic forms. Not all the non-metals, but generally non-metals can exist in allotropic forms. So did you understand, children? What's the difference between the physical properties of metals and non-metals? The next topic we are going to learn is reactivity series or activity series. So we can call it as activity series or reactivity series. So let's see what it is. It is a new term for you. All the metals do not show the same kind of reactivity. Some are highly reactive and some do not show any reaction. So we know of so many metals are there. Of all these metals, all are not showing the same reactivity, property of reaction with other elements. Some are highly reactive and some do not show any reaction. So based on their action, these metals are made into a series. And that series is known as what? Reactivity series. So a series of metals arranged in a decreasing order of their reactivity is called a reactivity series. A series of metals arranged in a decreasing order of their reactivity is called what? Reactivity series. So here you can see a series of metals started from potassium and ended with the gold. So the most reactive metals are placed at the top of the series and the least reactive metals are placed at the bottom of the series. Here you can see in this series, this is the reactivity series. Okay, and in this series, the metals which are placed at the top are the most reactive metals. And the metals which are placed at the bottom are the least reactive metals. And the metals present at the top, that is the most reactive metals, displays the metals below them in the reactivity series. So, the metals present at the top can displace the metals below them in the reactivity series. So, you know what is displacement reaction. You have studied in the first chapter, that is chemical reactions, a displacement reaction and a double displacement reaction. So, this displacement reaction is based on the reactivity series. Here let us see how the elements are arranged. So, in the series, the first element is what? Potassium. Then sodium, calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, gold. See, hydrogen is there in between. You know, all other names, whatever you are seeing is hard metals, but there is one gas in between, hydrogen. So that is the one which we are taking as the standard. Okay, the metals which are arranged above hydrogen are very reactive metals, and the one which are arranged below hydrogen are less reactive metals. Okay, now let's see what it says. See, if we consider a reaction where sodium and copper inverts. The sodium displaces copper from its place. Sodium displaces copper from its place. Understood? Because sodium is highly reactive than copper. Understood, children? See, if a reaction between aluminium and copper chloride, suppose a reaction between aluminium and copper chloride. The aluminium displaces copper from copper chloride and forms aluminium chloride. Copper the aluminium displaces copper from its position and will form aluminium chloride. So the highly reactive metals displace the least reactive metals from its compounds. So this is what a reactivity series. So a reactivity series or an activity series is a series of metals arranged in a decreasing order of their reactivity. A series of metals arranged in a decreasing order of their reactivity is known as what? Reactivity series or activity series. You know that gold is a metal, is an element which will not show any reaction. That is why you use aqua regia or royal liquid to dissolve gold. Gold will not react in any other liquids. If you use acids also, it will not dissolve in individual acids. So we are using what? Aqua regia to dissolve gold. So it's a least reactive metal. It will not react with any other uh, substances or liquids or elements. Understood? So reactivity series is a series of metals arranged in a decreasing order of their reactivity. And in this series, the elements which are placed at the top are more reactive than those which placed at the bottom. And a more reactive metal can displace the less reactive metal during a chemical reaction. And which is the gas included in this series? That is hydrogen. Now, let's see some of the chemical properties of metals. So already we have learned the physical properties of metals and the reactivity series of metals. Now let's go to the chemical properties of metals. So let's study about the reaction of metals with oxygen. Metals react with oxygen, form metal oxides. Metals react with oxygen, form metal oxides, which are basic in nature. Metal oxides are basic in nature. Here you can see metal, any metal, when combines with oxygen, it forms metal oxides. For example, copper combines with oxygen, forming copper oxide. Aluminium combines with oxygen, forming aluminium oxide. So metals, when react with oxygen, form metal oxides. Metal oxides react with acids and bases, form salt and water. So when metals react with oxygen, we get metal oxides. And when these metal oxides are treated with acids or bases, they form salt and water. For example, when aluminium combines with oxygen, we get aluminium oxide, Al2O3, aluminium oxide. And this aluminium oxide, if treated with hydrochloric acid, we get aluminium chloride and water, where aluminium chloride is salt. So aluminium oxide, when treated with hydrochloric acid, we get aluminium chloride and water. Metals react with oxygen for metallic oxides, and these metallic oxides, when treated with acids or bases, we get salt and water. Next, action of metals with water. Metals like sodium, potassium, etc. react violently with water and form their hydroxides, releasing hydrogen. You know that normally if we keep an iron piece in water, nothing will happen immediately. Or a gold piece if we keep in water, nothing will happen. No? So metals like sodium and potassium, if we keep in water, this reaction is very violent, very rigorous, and it forms its hydroxide by releasing hydrogen. And this reaction is an exothermic reaction. Is an exothermic reaction. You know what is an exothermic reaction? The reaction where the energy is released is known as exothermic reaction. So reaction of the metals like sodium and potassium with water is an exothermic reaction. During this reaction, it releases a huge quantity of, and as a result of this, if we drop a sodium pellet in water, it catches fire because it releases hydrogen gas, and due to the high heat which is produced, it catches fire. Now, sodium reacts with water, forms sodium hydroxide and hydrogen with the release of heat. Sodium reacts with water, forms sodium hydroxide and hydrogen with the release of heat. So, Na plus H2O gives NaOH plus H2. So, let's see what happens when calcium is treated with water. Reaction of calcium with water is less violent. So, how the sodium and potassium react with water? Calcium will not react with the same speed. This reaction is not violent. So calcium when treated with water, it forms calcium hydroxide with the liberation of hydrogen gas, and heat is also produced, but the heat which is produced is not as much as the heat released when sodium is treated with the water. So because of this, when calcium is treated with water, it does not catch fire because the heat released is lesser in amount. So it do not catch. Then let's see what about other metals. Some other metals like magnesium does not react with the cold water. Magnesium, you know magnesium ribbon. Magnesium that will not react with the cold water. If you drop magnesium in water, nothing will happen. But it reacts with hot water. If you put magnesium in hot water, it reacts. And let's see what happens to aluminium, iron and all. You know metals like aluminium, iron and zinc do not react with the cold water or hot water. If you put iron piece in hot water also, nothing will happen. Or in cold water, no effects. But they react with steam, forming metal oxide and hydrogen. They react with the steam. If steam is passed over this, they react and form metal oxides by releasing hydrogen. Understood, children? These are some of the chemical reactions of metals. So metals react with oxygen forming metal oxides. And these metal oxides, if we treat with acids or bases, forms salt and water. Then metals react with water in different ways. Some of the metals readily react with water, even with the cold water. For example, sodium, potassium, etc. These metals, these elements, if we drop in cold water, they react vigorously by releasing hydrogen along with much heat. Because of this heat production, so it may catch fire. Sodium pellet, you know, if you keep it on the surface of water, it moves with the energy. Now, for exhibitions and all, we are making the plastic boats to move in water by using this sodium pellets. And if the metal calcium is treated with water, It forms calcium hydroxide with the release of hydrogen heat. But the reaction of calcium with water is not as vigorous as that of sodium. And because of that, it does not catch fire. Sodium catches fire when we treat it with water, and calcium does not catch fire. And some other metals like magnesium do not have any action with the cold water, but it reacts with hot water. And metals like aluminum, iron, zinc, etc. do not react with either cold water or hot water, but they react with the steam and form metal oxide and hydrogen. We pass red hot steam, that is steam or water vapor, over these metals. They form metal oxides by releasing hydrogen. I hope you understood this much. A very small topic, but very, very important topic. So today we have learned about the position of metals in the periodic table and the position of non-metals in the periodic table, the difference between the physical properties of metals and non-metals, and the various definitions related to that, like ductility, malleability, sonorous, boiling points, melting points, etc. Then comes the reactivity series or the activity series, where the metals are arranged in a series based on their reaction. Then we have seen that the metals which are arranged at the top of the reactivity series displace the metals which are arranged at the bottom of the series. And finally, we have learned about the chemical properties of metals, that is one or two chemical reactions. The action of metals with oxygen and the action of metals with the water. These are the things that we have learned today. I hope you understood. Go through this topic 2-3 times. Try to understand it. And if you are getting any doubt, you can clarify it. Thank you.